So how's everybody doing out there? Well, welcome to day 12 of Corona Online School. And so today we're actually finishing up chapter 12, even though we do have some more stuff that we're going to be working on Wednesday. So just to let you know, we do have our first exam will be, or second exam will be next Monday. So I think it's next Monday. Well, I'll let you guys know if I'm wrong, but it's either next Monday or next Wednesday. It's one of the two. So I'm trying to remember exactly. But either way, so the last thing we want to talk about in this chapter are similar triangles. And so we talked about congruent triangles, and we knew, now we know what the rules are to see when two triangles are congruent. So now we want to see what conditions hold to make two triangles similar. So typically at this point, if we were in class, I'd have you guys look at these 6 triangles, and you would want to try to figure out which ones, without even knowing anything about similarity, which ones do you think seem like they would be similar or not. So pause the video for a little bit, look at these guys and try to figure out which ones you think would be similar, write them down, and then we'll come back in a little bit just to see if we all came up with the same thing. All right. So hopefully, while you guys were looking at these, the ones that you determined to be similar were like this one and this one. Let's get pink. So this one and this one. And then finally, let's do blue. Those guys. So hopefully those were the ones you determined to be similar. And hopefully what you kind of recognized is sort of what made these guys similar is that they all had the exact same angles. So another way to think about it is they had the same shape, but their sizes were a little bit different. So in some cases, some were, you know, like the two pink ones, one's bigger than the other one. Same thing with the kind of orange colored ones. So one's always going to be a little bit bigger, one's always going to be a little bit smaller, but they're always going to have the same general shape, and they're always going to have like angles that are the same. So what that means is the sides can't be equal, obviously, because if the sides and the angles were equal, then we would know they'd be congruent. And so in this case, we're trying to show that they're just similar. And so we'll see that what we need is we need the sides to at least be in the same ratio. They have to be the same proportion in order for these guys to be similar. So let's take a look. Let's flip to the next page here. And so that's kind of what we say here in the definition. So similar triangles are triangles in which all the corresponding angles are congruent and their corresponding sides are in the same ratio or proportion. And so the ratio that they come in is what's called the scale factor of the two triangles. So let's jump into a little example here just so we can see. And so what we're going to look at are triangles ABC and EDF. And we want to see if because they were the ones that were colored pink. So we knew that their angles were the same. So now we want to test to make sure that the ratios of the sides are the same. So let me jot down real quick what everything is. So AB was side length 2.25. And ED was, 3. So BC is 2.25 square root of 3. These are some beautiful numbers, aren't they? Good thing is nice things are going to happen here in a second. So DF is 3 square roots 3. And then finally AC is 4.5. And EF was 6. Okay. So what we're doing is we're taking the ratio. So in this case, we're putting the bigger triangle on top. So in this case, we're going to put the 3 on top and then the 2.25. And I'm just going to go ahead and write them all down real quick. And then 6 over 4.5. Well, the cool thing about this one in the middle is because we have a square root of 3 on the top and the square root of 3 on the bottom. They're just going to cancel out anyway. So at least looking at the top two, it looks like those two sides are definitely in the same ratio because we have the same number on the top and the bottom. And if we were to actually calculate what this was, we'd get 3 divided by 2.25 gives us 1 1/3, or another way to think of this is 4/3. So in this case, it's usually better to think of this as an uneven fraction instead of a mixed fraction, and you'll see why in a second. So that means that this is the same. This one will be 4/3 also. So now let's just do 6 divided by 4.5 just to compare. And lo and behold, same thing. So that's good. So what we've found here is what's called the scale factor, or in this case it's the ratio of the lengths, but it's also going to be the scale factor for this triangle. And so when we talk about two triangles being similar, we use this little teeny weeny kind of the tilde, almost like a tilde sign, to represent that they're similar. So triangle ABC is similar to triangle EDF. And again, we've proven that now because we know all the sides are in the same ratio and the angles were already congruent, which we knew. So when we're talking about this scale factor, what it's doing is it's telling us a way, basically what numbers would I have to multiply the sides by to get the other triangle. So when you're going from like a smaller triangle to a bigger triangle, you're going to want to have the bigger number. And when you're going from a bigger triangle to a smaller triangle, you'll want to have the smaller number. And so the idea is the scale factor is always going to be the reciprocal of the other one. So 4/3 is one scale factor, but I could have just as easily have done AB over ED, and that would have given me 3/4 in that case. So the scale factors are always reciprocals of each other. That's why it's nicer to think of them as uneven fractions instead of mixed numbers in this case. So if I'm trying to go from ABC to EDF, let me just check. So ABC, remember, was my smaller triangle. Then that means I need to multiply it by a bigger number in order to turn it into EDF. So in this case, the scale factor going from small to big would be 4/3, the bigger number. And the scale factor from going to the bigger triangle to the smaller triangle would be the opposite. So I'd want to go 3 to 4 or have the smaller number there. So always kind of keep that in mind whenever you're doing the scale factor, because it's different depending on which way you're going, whether you're going from the smaller triangle to the bigger or the bigger to the smaller. But you're always going to do, the bigger numbers are always going to go from the smaller to bigger. The smaller number is always going to get used from the bigger to the smaller. So just kind of keep that in mind. All right. So with that in mind, I'm going to let you guys work through practice 2, which is checking the similarity of the other 4 triangles that we already kind of determined are similar. So pause the video at this point, go through, check the ratios, make sure they're the same, identify how these triangles are similar, again by matching up the vertices that match up just like we did for congruent, and then figure out what the scale factor of each of these guys are, again going from, in one case, bigger to smaller and then smaller to bigger. So, all right, so when you're done with that, come on back and we'll talk a little bit more about this. All right, very good. So part 3, so I've got a little PowerPoint slide for you guys to actually write down the 3 properties. So unlike congruence, we had 4 properties to tell whether something was congruent. We only have 3 for similarity. And if you notice, 2 of them are actually kind of the same. So 2 of them are called side, 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 and side angle, side angle, side. So that's why I've included the similarity property with it, so you know the difference between the 2. But then we're missing some of the other ones, like angle, angle, side, and stuff like that. But if you've noticed, we picked up a brand new one, angle, angle property. So if you remember, we talked about, could you say that 2 triangles were congruent if they had all 3 angles the same? And we showed a bunch of examples that said no. But for similarity, this is perfectly fine. So if you know 2 angles are congruent for a triangle, then automatically those two triangles are similar. You don't have to do anything other than just note this property. And again, I'll talk about this in the PowerPoint and show you some examples and stuff like that, but I'm just kind of giving you a brief overview. So side, side, side is kind of the same way. So, but instead of being the same, the sides have to be in the same ratio. So if we can do like we did above and we can prove that they have, like all three sides have the same scale factor, then that shows that those two triangles are similar. And then finally, side angle side tells us that the two sides that are, the two sides of the triangle are in the same ratio, and the angle in between them is congruent. So again, remember, this A in the middle is there for a reason. So the angle, just angle, has to be between the two given sides. So if the angle is not in between those two sides, then we can't apply this rule. Now that doesn't mean we couldn't maybe find another rule that we can use, but that's why it's side angle side. So, and again, the picture you'll see in the definitions will show that. But again, so the sides have to be in proportion, and the angles have to be congruent, and the angle has to be in between the two sides. So with that in mind, what I want you to do is take a look at like practice 3 and see if you can figure out, whether this guy is congruent or not using those three, or similar using those three properties. Same with practice 4, 5, and 6, 7. So check all those guys out, see if they're all in proportion. And then what I want to do is show you some examples of how we can actually use similarity to solve different types of problems, word problems, things like that. So at this point, pause the video, go and do those practice up to 7. When you're done, come on back, and then we'll look at a couple more examples. All right, so let's look at example 2 real quick. Hopefully you guys had no problems with those practice. If you did, shoot me a message tomorrow so that way I can help you guys out. So in this case, we want to first figure out, if these two guys are similar, how do we know they're similar? So we should look and see what's given. So in this case, we've got two angles. And remember, that's all we need. So as long as we have two angles that are congruent, in this case, we've got 21 and 21, 110 and 110. So in this case, this is congruent by the angle-angle property. So I probably should have said similarity, but since there's no angle-angle congruence property, it's pretty clear that what we're talking about here. And so now what it wants us to do is solve for Km and ML. Oh, hold on a second. I seem to have... Oh, I wrote this wrong. Duh. Hold on, because I know Km and I know ML. So what I don't know, sorry, is PO. Oops. And I don't know PN in this case. So the first thing I need to do is kind of figure out, well, how are these sides actually matching up? So at this point, I need to write down, well, what is the similarity between these two triangles so I know how the sides are all going to match up. So in this case, let's call the first triangle KML, and then that's going to be similar to, so K had the 21-degree angle, so that means it has to match up with the triangle over here that has the 21-degree angle. So that means I need to put my N first. And then from K, I went to M, which was an unknown angle. So that means I want to go to the unknown angle of this triangle, which is P. And then finally, we went to L, which was the 110-degree angle. So that means I want to go to O. And then we'll cycle back around again. So in this case, I'm trying to find PO. So let me highlight that in orange here. So I'm trying to find that side. So what I need to do is figure out, well, which side does that match up with? So if I go up to my triangle, PO were the last two letters, which means that has to match up with ML in this case. So my PO, can't believe I messed this up this bad. So PO is going to be the same as ML, which is going to be 5 centimeters. So I'll write ML above here and then scratch this ML out because, again, I messed it up. All right, so now finally we want to find PN. So let me highlight PN in pink. So that's going to be that part. And so again, if I look at my KML, if I look at my original triangle, PN is going to be like the NP. So that means I need to use KM or MK for my drawing. So that's going to be this part of the triangle. And so again, I can see that, oh, so this won't be 5 centimeters. Hold on, let me go back and talk about this again. Sorry. Ugh, man, I'm really butchering this problem up. So we know that LM, or ML, is equal to 5 centimeters, and we know that the side that we're interested in is PO. And so the goal is we need to figure out what it is. Now, if these were congruent, then it would have just been 5 centimeters and everything would have been totally fine. But again, I'm kind of like skipping some steps here. So since they're similar, that means that their sides have to be in the same ratio. So what we need to do is actually figure out what sides we actually know so we can figure out what the ratio is. So in this case, we know KL and NO are similar sides and they have both numbers filled out. So off to the side, we should go up and do KL over NO equals, or ON, sorry, should be, so KL over ON is going to be 12 over 9. So 3 goes into both of these guys. So this gives us a ratio of 4/3 in this case. All right, so that's perfect. So now let me go back to the ML and PO now that we've got our scale factor. So this again is our scale factor. And so what we've got is, so let me make sure I actually label these correctly. So ML and PO. So I did label those correctly, which is good. So we know that since this is a similar triangle, that this has to be in the same proportion, so 4/3. And so again, since I put the bigger triangle on top, I need to make sure I write the scale factor as 4 over 3. And so now what we want to do is do a little solving to actually figure out what the question mark is in this case, or I'll just go ahead and replace it by an X. And so what we want to do is cross multiply this guy. So we're going to get 4x equals 15 centimeters. Divide both sides by 4. And so we see that x equals 15 divided by 4, which is 3.75 centimeters for the first one. All right, so now that we've done that, now we want to do the exact same thing for PN. So again, PN in this case is this pink one, and so we want to match it up with, it looks like KM, so we make sure I get them in the right order, so I got that. And so again, I can't just write it down, so even though I know KM is 14 centimeters, I don't know what the question mark is, but again, I know since these are proportional that I know that this has to equal 4 over 3. So again, I can do the same thing, replace the question mark by an X, and solve this guy, again, by cross multiplying. So we get 4x equals 42 centimeters. So again, divide both sides by 4. And so we get x equals, so 42 divided by 4. Oops. Is 10.5. So that's how we correctly find out the proportions of these guys. So again, we can't just copy them straight off. So the first thing you have to do is use the given side where both of them actually match up. So in this case, where we can actually calculate the scale factor, then use that scale factor to calculate all the other side lengths from there. But, all right. Any questions or anything like that? All right, perfect. So example 3 is doing the same kind of idea, except in this case it's sort of laid out for us. And so what you're going to see in these word problems that we're dealing with, there's usually going to be two different types of similar triangles that you're going to have. So you're going to have this one where the similar triangle is actually embedded inside the other triangle. Or the other choice is going to be like example practice 9 for you guys to work on, where the similar triangles are kind of a mirror image of each other. So in this case, the triangle, little teeny weeny triangle on the right, is similar to the triangle on the left. In both cases, these are always going to be by angle for the most part, because, in this case, oops, got the wrong thing on there. In this case, these are vertical angles, so they're going to share this angle. And then both of these guys over here are going to be like right angles in this case. So when we're doing these, we don't necessarily have to verify why they're true, but it's pretty much always going to be angle, and the two angles are going to be either a shared angle like we have above. So in this case, this small triangle and the big triangle all share that angle S in this case. And they both have right angles. So again, by angle, we know these guys are similar. So again, we don't always state why, but that's usually going to be the reason why for these guys. So for example 3, I just answered that. So in this case, it's going to be angle, because they, angle S is congruent to angle S for both of them. And then they both contain that 90-degree angle. Or if I want to say angle S, Y, Z is congruent to angle S, T, U. In this case, by angle. All right. So again, the idea is I want to solve this guy for x. So what I want to do is actually, I don't need to know what the scale factor is, but I do just need to set the sides that are in proportion to each other equal to each other. And so typically the way I do these, I kind of do them based on the triangle. So in this case, the two sides of the triangle, or the small triangle that I'm going to use, are going to be the x and the 7. So my first fraction, I'm actually going to set up as that ratio. And so now I want to set the next sides up so that they actually correspond, that they actually go together. So in this case, let me erase these. The bigger triangle in this case is going to be, let me use a different color. So in this case, side SZ is going to be similar to side SU. So when I actually set up my top equation, in this case, I have to take that x and 6 and actually add it together. So in this case, that big side length is actually going to be x plus 6. So kind of keep that in mind. Sometimes when people do this, they just want to grab the 6, and that's not going to work because you're missing, like at that point, you don't even have a triangle. Like you've only got, kind of a trapezoid in that case. And so the goal is we want to have a triangle. So we have to include both the x and the 6, so we actually add those sides together. And then we're going to do the same thing for the long side on the bottom. So side SY is similar to side ST. And again, what we need to do is add that 7 and 5 together to give us a 12. Now that we've got our two ratios set up, now we're good to go to actually solve this. And we solve it just like we did above. We're going to cross multiply. So in this case, I'm going to get 12 times x equals 12x. And then 7 times x plus 6. And so I'm just going to write this as 2 steps. If you can do it in one step, that's fine. But I'm just going to kind of write it out first as 7 times x plus 6. And so now we want to distribute that 7 to both pieces. So in this case, we get 12x equals 7x plus 42. And so now we need to get all the x's to one side. So in this case, since I've already got 12x by itself, I might as well just move the 7x just to make life easier. So that gives me 5x equals 42. And then finally, to get x by itself, we'll divide both sides by 5. So x equals 42 divided by 5, which should be 8.4 in this case. So this side length here would measure 8.4. And that way it'll keep everything in proportion and it'll allow those two triangles to stay similar. So again, all the word problems are going to look exactly the same way. So if you want, go ahead and take the time to do practice 8 and practice 9. So I just gave you an example of one of each type instead of hammering you with a bunch of them, just to make it a little bit easier. But again, if you get stuck on either one of these, definitely let me know. If you have any questions about anything going on tomorrow, let me know. Otherwise, I will see you then, and good luck.